Okay, welcome back to another tutorial for Laerd. So this tutorial is going to be, let's see, week 6, the Wilcoxon signed ranks test. So I go here and here. So here we are with the Wilcoxon signed ranks test. This is the introduction. Again, you can read this if you need a little help in this area. The data starts on page 6, though. So the example used here is a researcher wants to test a new formula for a sports drink that improves running performance. So this is the same scenario as the paired samples t-test that we did previously. So I'm going to download this example. And again, I'm going to make this small so I can utilize both screens, or this one screen, so you can see everything that I'm doing. Okay, so we got your example. You've got your data set up already here. So on the next page, we show you how to set up your data. When you have done this, you can move on to dealing with missing data if you have any, and then calculate a difference score, which you need to do this early stage so that you can test one of the assumptions. So click on the next page. So you're going to have two variables. In this example, there's carb and carb protein. These are already set up for you. Your screen should look like this, and it does if you make this longer. But I'm going to put it back because that way you can see it. This explains what's going on here. So everything is entered. It should look like this. Here's the data view. Looks like that. So if you have two ordinal variables, the variable view will look like this, which we don't. Explains that. So we're going to move on. If you're not clear on how data gets set up, you can read this recommended guide. But however, if you're confident you have set up your data correctly, how you proceed now depends on whether you have missing data. If you do not have missing data, you can jump to page 9. So let's look and see. We do not have missing data. We're going to jump to page 9. Calculating a difference score. So for a Wilcoxon sound rank test, the null hypothesis is tested in terms of the differences between the paired values, not the values of the pair groups themselves. Therefore, before carrying out the Wilcoxon sound rank test on your data, you first need to compute the difference score for each paired variable and to store these in a new variable. You will also need this difference score in order to produce descriptive statistics later in the guide. So first things first, I'm going to click on Transform, Compute Variable. You'll be presented with a compute variable dialog box as shown below, which is what you see on my screen. Again, this is a little different here, but it's the same variables. Type difference into the target variable, just like we did on the previous one. And then we're going to put this minus this. You're telling it to subtract the differences. So click on OK. You'll be returned to the data view, which we're not on the data view, so I'm not sure what says that. You'll be returned to the data view where you will see that your new variable has been created and populated with different scores. And there they are. Now that you have calculated these different scores, you can analyze your data using the Wilcoxon signed rank test. So up to this point, we've done the same thing as previously, but now we're going to do this new test. So I'm going to click on the procedures section. This section sets out the procedures that can be used to run a Wilcoxon signed ranks test, as well as produce appropriate descriptive statistics. So this is going to be one of the ones that has either the new or the legacy, and we're going to use the new procedure. So this is where you have to be careful not to accidentally do a legacy step, which I have done before. It's very easy to accidentally do that. So just be really careful. Analyze. So I need to click on my SPSS. We're going to do analyze non-parametric tests related samples. You will be presented with a non-parametric test, 2 or more related samples dialog box. Click the Fields tab. You'll be presented with the following screen. Transfer the variables, transfer the variables carb and carb protein from the fields box. So I'm going to shift and click and put it in the test fields. Click run. Now that you have run the Wilcoxon signed rank test procedure, you need to generate medians for your data. To do this, skip the next page, which deals with the legacy procedure, which we're not doing, and move on to page 12. Generating median statistics. Unfortunately, the non-parametric method does not generate the median for each group, which is a common way of expressing the central tendency of the groups when running a Wilcoxon signed rank test. To correct for this, you will generate the medians using the means procedure as shown below. So analyze, compare means, means. You'll be presented with the means dialog box, which we are. Transfer carb, shift carb, protein, and difference into the dependent list. Click the options. You will be presented with the means options dialog box as shown here. Transfer median from statistics and deselect mean, number of cases, and standard deviation. And I'm just holding down the shift key while I click on them to highlight all of them. And we're going to put those back in the statistics box. And that way you just have median here, because that's all you want. Click continue and click OK. Now that you have generated medians, what you should do next depends on whether you have used the new or legacy procedure in SPSS statistics to carry out the Wilcoxon signed rank test. However, in both cases, this will involve assessing your data for the critical assumption of the Wilcoxon signed rank test. That is, that the distribution of differences is symmetrically shaped, which we discussed on page 3, if you read that. Whether your data passes or fails this assumption will determine the suitability to analyze your data. We discuss this further in the assumptions section on the next page. This is going to tell you your assumptions. You can read that if you'd like to. In the pages that follow, we show you how to determine whether the distributions of the differences between your 2 related groups are symmetrical in shape and what options you have if they are not. If you ran the new procedure, which we did to carry out the Wilcoxon signed rank test, you should go to page 14 now. So I'm going to click on that. So distributional assumption, new procedure. Having run the Wilcoxon signed rank test procedure, you will be presented with a hypothesis test summary table as shown below. And it is here. It looks like this. However, for the moment, you can ignore the results of the table. Instead, double-click on the table to launch the model viewer window. This will expose extra information about the Wilcoxon sign rank test. So this is not going to work. It did, or it has not worked in the past. I'll try it, but I don't think it's going to work because I think what it is that it's all here already. So if I double-click on it, it does not look like what they have. So just move along. And you can see the histogram is the chart located in the top right-hand pane of the model viewer. So this is your histogram, and this, here it is on your page. That's why it's not opening in a new box. It's already here. You can use this chart to determine whether the distribution of the differences is symmetrical, as discussed below. In order to use the Wilcoxon sign rank test to determine if there is a statistically significant median difference between two related groups, you need the shape of the distribution of the differences to be symmetrical. If you cannot declare that the distribution is symmetrical, you cannot use the Wilcoxon sign rank test unless you're able to apply a transformation to the data. You can use different types of graph to visualize where the distribution is symmetrical, but we will use a histogram because it is the default chart produced by SPSS Statistics' new non-parametric test procedure. This chart is displayed here. Looking at this histogram, you need to make a judgment about whether the distribution is symmetrical. By visually inspecting the shape of the distribution of different scores, you can see that the scores do appear to be approximately symmetrical. They don't have to be perfect, especially when you have not very many people in the study. From the results above, we can use the Wilcoxon sign rank test to analyze our data. However, if the distribution does not look symmetrical, you have three options on how to proceed. So we're going to use branch 1. If the distribution of differences is symmetrically shaped, you can analyze your study using the Wilcoxon sign rank test and should go to interpreting and reporting new procedure. We're not going to need these other branches because we do have symmetrically shaped data. So this is still the new procedure. The results of Wilcoxon's sign rank test is found in the hypothesis summary table as shown below. However, before we evaluate this table, double-click on the summary table. This will launch the model viewer. We're not going to do that because it's already on your page. You will see that it's replicated. Let's see. With the right-hand pane with the table companion. So we already have that. We don't have to open that. You can see how many participants had improved performance using the carb protein rather than carb only. How many remained the same and how many had worse performance. Positive difference, negative difference. To be clear that this is what the histogram is informing you, look at the x-axis label, which is labeled distance run in kilometers for carb protein trial, distance run in kilometers for carb only trial. This informs you which related group is subtracted from the other. This histogram shows that 17 participants had a positive difference, meaning that the carb protein drink elicited greater distances run. One participant had a negative difference. Here is in the red. Furthermore, there were two participants where the type of drink they drank had no effect on their performance. The two ties, where distance run was the same for both trials. Trying to see where that shows. So that would be where it's right here at 0. You can report these results as follows. Of the 20 participants recruited to the study, the carb protein drink elicited an improvement in distance run in 17 participants compared to the carb-only drink, whereas 2 participants saw no improvement and 1 participant did not run as far. So I'm going to copy that. I'm going to put this. I'm going to put this just here at the bottom. There's the tiles. Okay. Now that we know the number of participants that either benefited, experienced no change, or decreased their running performance after drinking the carb protein drink rather than the carb only drink, it would be useful to know the median difference in performance and whether this difference is statistically significant. To know this, we can use the results of the Wilcoxon sound rank test, which is discussed next. Again, the new procedure. The first column of the table expresses the null hypothesis in terms of the median difference between the two related groups. Notice that the aforementioned statement includes the name of the labels you gave the two variables. Therefore, this statement will likely be different for your analysis, reflecting the names and labels you gave your variables. We didn't change it, so it should be the same. The test column indicates that it is the Wilcoxon sound rank test. The SIG column is obviously one of the more important ones because it displays the statistical significance. So using that significance value, it is possible to reach a decision whether to retain the null or accept the alternative. The decision made based on this p-value is presented in the following column. So you're going to reject the null because the significance is 0, which is less than p of 0.05. I'm going to skip this section. You can see from this table that our test statistic is 3.672. And there's this. So that means Z equals 3.672. So if you wanted to write that up, it would be 20 participants, etc. You can read that. So I would go ahead and just copy that so I have it. Insert. And put it there. On the next page, we explain how to report the null and alternative, interpret the median difference, and bring all the analysis together into a single paragraph, which you can add to your report at the end. Still the new procedure. These are the null and alternative hypotheses. This is more information on median values. Which is here. So basically what this negative 0.1350 is saying is that the median increase in distance run with carb protein versus carb only is 0.135 kilometers. We know that from the result of the Wilcoxon sound rank test that this median difference is statistically significant. You, for consistency, can consider reporting the medians of the two related groups. Unlike the mean, the median difference does not have to be equal to the difference in the medians. In the next section, you will see how we can add these results to the write-up. So putting all our information together, we can take this paragraph that they've written for you so nicely, copy that. And I'm going to just put it right here at the bottom. And there it is, all of your information. I'm going to go back to Laerd. This is legacy on 21, 22 is legacy, 23 is legacy, 24 is reporting. So we're going to skip and go there. So when you report your results, you can focus on the main findings, but it's good practice to also report the results from the assumptions tests that you carried out. In this section, we describe how you can report your findings when you have used the same study design as our example. but also if you have a study design that involves determining if there is a median difference over time. In both scenarios, we show you how to report a statistically significant and non-statistically significant Wilcoxon sign rank test. So here's how another write-up for a statistically significant result, which I feel like we have covered that, so we're going to leave that alone. That's if you needed to report a non-statistically significant result, which we don't this time. This median difference over time we're not going to do. And then 25 is references. So that means you're done. So I'm going to show you what I have. It should look similar to this. You should have your hypothesis test summary here. This one here too. There's your bar charts. There should be 3 of those, your case processing summary and your report. And then you should have your interpretation down here, the big interpretation. You can add in the smaller sections of interpretation if you would like to. It's not mandatory. As long as you have your main interpretation down here, you should be good. So that's really it for this one. That's all that's expected for what you turn in. I'm going to show you on this video because I thought about this on the previous video that I wanted to show you all how I'm turning it into a PDF in case you haven't done this before and or you haven't tried this before. I know some of you have already tried everything, but just in case. So I go to File and then I go to Export. I have a file name here, so I'm going to change this to what are we doing? I forgot. Hang on. Okay. So Wilcoxon sign rank test. I'm sorry, I cannot remember that. I was having a moment. So I go to File, Export, and I'm going to change this file name to Wilcoxon sign rank test output and browse because I want to put this in my statistics folder. Oh, I guess I need to type that again. So I'm going to save it in my statistics folder and say okay. And it's exporting it as a PDF. So I'm then going to save it as a SPF SS file just in case. And then I can close it. And I'm going to save that too, just for in my statistics folder. And then I can close that. I'm not sure if this is something I need to save, but I'm only doing it just in case. And that's it for this tutorial. So if you have questions, please let me know.